Okay, I have three separate questions here that are probability questions based on the normal distribution. One has to do with kind of your standard normal distribution question, and the other two are related to the central limit theorem and sampling distributions. Okay, so I have three formulas here, and they're all z-score formulas, which we'll need, but they're all kind of slightly different forms based on the underlying distribution. All right, so let's take a look at the first one. Assume that 0.0995 is the proportion of passengers that miss a flight for which they have a reservation. Suppose a flight has 290 reservations. What is the probability that 25 or more passengers will miss the flight? Okay, so first of all, the big hint here is that it's a proportion problem. So I think, and it's a question about probability. So our process here is to find the z-score, and then we can look it up in our z-score chart. All right. So first of all, what's given? Well, we have the known proportion of missed flights is 0.0995. That's P. And our P hat's a little disguised here. For this scenario, 25 out of 290 are missing. And we'll use the more than when we write our probability statement. Okay, so that's P hat. So I could calculate that if I want to, plug it in if I want to change it to a decimal. So I'll go ahead and plug that in, and I get 0.08621. 0.08621. And now I can write my probability. What's the probability that I saw this result? Given that this is the real proportion. Okay, and for I always go and write a statement for z right away, because that reminds me to calculate the z-score, which in this case would be 0.08621 minus 0.0995 divided by the square root of 0.0995, that's P, and Q is 1 minus that, which should be 0.9005, all divided by N, which is 290, my sample size. Okay, run that through your calculator. You should get something close to negative 0.76. Okay, and this is, again, anytime we have probability greater than. So here's in my standard distribution, I'm looking for this region, right? So what the chart gives me, if we're using the chart approach, it gives me this region. All right, so I can do two things. I can do like that shortcut where you just look up the positive value, right? Because that gives me the positive guy lives over here and it's symmetric. So to the left of that would be the same as this black area, right? Or officially, we do the 1 minus the probability that z is less than negative 0.76. Okay, and from that, you should get a final result of about 0.7764. That's your probability. All right, how about the next one? The reading speed of second graders is approximately the normal mean, standard deviation. One student, there's your giveaway. One student is chosen at random. What's the probability they can read 95 or more? So that's this formula. All right, and I'll just read the next one because it's connected. Reading speed of second graders, same parent distribution. Then it says, what is the probability that the mean reading rate? And that's my central limit theorem version, so that's that guy. Okay, so this one set up would just be the z-score is, well, we could set it up the same way. The probability that one student can read more than 95, so x greater than 95. What is that probability? It's the same as probability that z is greater than something. Find the z. 95 minus the mean of 90, all divided by the standard deviation of 10. and that's 5/10, which is a half. Okay, so I need to find the probability that z is greater than a half, or shortcut, probability that z is less than negative 0.5. Or the official way, I hope I'm not giving you too many ways to do that. Just pick one, either this way or this way. Should give you the same result. Let's see what we get. Let's see if I can pull up the z chart for this one. Okay, so it's let's do less than the negative 0.5. Let's see what we get. Negative 0.5 right here, 0.3085 appears to be my answer, 0.3085. Okay, so about a 31% chance there that if you pick one student at random, they're going to read more than 95 words per minute. Okay, now here's the next scenario. You pick 12 students, you figure out the mean reading rate, and then you answer the probability that the mean reading rate is more than 95 words per minute. Okay, so that's an entirely different question because the standard deviation is so much smaller, right? So we've seen these central limit theorem problems. These are much more condensed distributions, which will definitely affect that solution. All right, so let's take a look. I'm going to run it through the formula here, and it's still going to be 95 minus 90 up top, right? But the question is, how does that denominator differ? We're not going to divide by 10. We're going to divide by 10 over root 12, right? So it goes like this. So again, we get started off the same way to organize ourselves. Probability that x bar, the mean reading rate, is greater than 95. And that's got to be this probability that z is greater than something, but it won't be the same as that z, right? Let's find out. That should be 95 minus 90, but we're going to divide by 10 over root 12. Okay, that'll give me a different z-score. Let me take a look real quick. And that is 95 minus, oh, that one we know, that's 5. 10 divided by root 12. So you should be looking at something like this, 5 over 2.88. For my z-score. I'll call it 1.73. Okay, again, we're going greater, so the shortcut is to go less and then the opposite. And let's see what we get on my z table this time. Let's see here. Negative 1.73. 0.0418 is the probability. Okay, now here's a way to check your work. I want to show you what you can do in StatCrunch real quick. So let me show you StatCrunch. Give me 1 second to pull it up, and we can take a look at how to take a look at these guys in StatCrunch. Okay, so I'll go to stat calculator, and this of course is normal, right? So basically what I have to do here is type in the mean and standard deviation. So for example, for that last question, we'd have to calculate the standard deviation, which we did have right here, this 2.88675, and the mean being 90. So let's see if we can get that same answer here. So the mean was 90. Standard deviation was 2.88675, I think. And we wanted the probability that x was greater than, oh, the screen here, greater than 95. And we're close. We're not exactly there, but it gives you pretty close to the same result that we got, which was 0.0, that's 0.0416. We got, what did we get? I got too many files open here. We have, oh, here it is, 0.0418. So close enough.